Hey guys, happy Monday. I'm having a little bit of PTSD making this because it reminds me of the spring semester when we were not in person, so hopefully it doesn't do the same to you. All right, in class on Thursday, we did not have a chance to talk about the degree of a polynomial, so I want to make sure that we have that under our belts before we see each other again in class on Tuesday. So just a quick refresher. We can classify a polynomial either by its degree or it's by its number of terms. And in class on Thursday, we classified it by the number of terms. So we had that table that said number of terms, and then what it would be named, and then we just gave an example. All right, so if there was one term, it was called a monomial. And our example was 5x squared. If it had two terms, it was called a binomial. And that we did, I think, 5x squared plus 3x. And then if it had three terms, it was called a trinomial. And I think we did 5x squared plus 3x, maybe plus 7. I can't remember what the constant term was. Then we got to a polynomial with four terms, and we did not have a special name for it. It was called a polynomial with four terms. And again, if you watched that video already that I assigned to watch before this one, he just calls it a polynomial, which is true. It is a polynomial, but when we want to get a little bit more specific, we can say it's polynomial with four terms. And an example of that might be 8x cubed plus 5x squared plus 3x plus 7. And as we discussed in class, we want it to be after we've combined like terms, that it's four terms. So if you try and do something and say, well, let me add another 3 here to make it a polynomial with 5 terms, that doesn't work, because when we combine like terms, we just get down to 4. So make sure the like terms are combined before you classify it. All right, so then we said in general that if you have n terms, it was called a polynomial with n terms. And again, I'm not going to make up an example there. You can make up one for yourself depending on what n is. Okay, so then the degree of the polynomial really talks about the highest exponent. And so we could do the same thing here. We could say the degree. We could say the name. And we could give an example. All right, so if the degrees could possibly be 0, 1, 2, 3, 4, 5, 6, and then n. Again, it doesn't mean that there aren't polynomials with 7 degrees, but we'll just stop naming before we get to that point. All right, if the polynomial has 0 degree, that means the highest exponent is 0. That is just called a constant. And again, you should have seen that in the video that I just assigned before that. What it means is the highest exponent on any variable is 0. So let's say we had something like 3x to the 0. Well, what is x to the 0? It should just be 1. So this is really the same as 3 times 1, or just 3. That's why we call it a constant, because the variable with an exponent of 0 really just becomes 1, so there is no variable. Okay, if the highest degree is 1, it means or if the degree is 1, it means the highest exponent is 1. This is called linear. So that would be something like 3x minus 1. All right, if I look at this variable right here, it's got an implied 1. That's the highest exponent in here, because again, this is an implied x to the 0, which doesn't mean anything. So we just say it's 3x minus 1, and that has the highest exponent of 1, therefore it's linear. If the highest exponent is 2, that's called a quadratic. All right, that might look like negative 4x squared plus 3x minus 8. All right, when we look at all the exponents here, there's a squared, there's a first power, and again, that 8 with no variable implies there's an x to the 0 there, which has a power of 0. So the highest is 2, and that is called quadratic. All right, next comes cubic. That would look something like 3/4 x to the third minus 4x squared plus 3x minus 8. Remember, it's okay if the coefficients are rational, just not if they're irrational. So that still is a polynomial. The highest exponent is a 3. Everything else is lower than that, and so it is a cubic. If the highest degree is 4, the highest power is a 4, this is called a quartic. That might look like, I don't know, negative 0.6 x to the fourth minus 3/4 x cubed minus 4x squared plus 3x minus 8. Again, nobody would ever do that and combine a decimal and a fraction at once, but I just want you to remember that it's okay. It's decimal as the coefficient as long as it's either repeating or terminating, which negative 0.6 is. Here the highest exponent is a 4, all others are lower, so it's called a quartic. For 5, this is called a quintic. I'm just going to be boring here and just do x to the fifth minus 0.6 x to the fourth minus 3/4 x cubed minus 4x squared plus 3x minus 8. Highest power is 5, so it's called a quintic. When we get to 6, we stop naming, right? And we would just say that this is a 6th degree polynomial. And again, you could make up something there, just put a 6th power in front of what we've already been building upon. And in general, if it has something higher than 6, we'll just call it n. It's called an nth degree polynomial. Right, now note that you can have something that's, let's go back here, that's a constant, like this 3, and we could also classify it by its degree. So I would say that this is, or by the number of terms, we could say that this is a polynomial of 0 degree, but specifically it's a monomial because it only has one term. All right, this one right here is linear, right, and it has 2 terms, so we could say that it is a binomial. It just so happens that I made these continue to go up 1 term each time. This has 3 terms. It's a quadratic, but because it has 3 terms, we would call that a trinomial. But I could just as easily have given an example of a quadratic. For example, negative 4x squared. That's still a quadratic because its highest power is a 2, but there's only 1 term, so it's a quadratic that is a monomial. I could have also done, again for this, negative 4x squared minus 5. Right, there is a quadratic because its highest power is 2, but it is a binomial because it has 2 terms. So don't think that all constants do have to be monomials, but linear could be either a monomial or a binomial. At least for our purposes, that's what we'll mostly see is linear that are monomial or binomial. Again, quadratic could be monomial, binomial, trinomial. We'll talk about some other weird ones in just a minute, but for the most part, we're going to be looking at ones that have a single variable. So notice how in each of these cases, I only used x's. But in just a second, we'll talk about ones that have more than one variable and how do you assign them a degree. And then can they be, monomials, binomials, trinomials, and so forth. Before I do that, I want to mention this idea of the leading coefficient. And this goes back to the previous video that you watched by that other guy, he talked about how you arrange the terms in descending order. So again, right here, we have the terms so that we have the 5th power, the 4th power, the 3rd power, the 2nd power, the 1st power, and the 0th power. Just to standardize it, we arrange them in that order. When it's in that order, we say the leading coefficient is the coefficient of the term with the highest power. So for example here, the leading coefficient would be 1. In this example right here, I've arranged them properly. So in descending order of power of their variables, the leading coefficient here is a 0.6, negative 0.6. In this previous example, when they're arranged in order, the leading coefficient is a 3/4. So it's always the coefficient of the term that has the highest power. Okay, I'm going to make a second video on what to do if you have more than one variable, just so that you can see what to do there.